Hello to my students. This is Mr. D giving you another math instruction video in Mr. D's math class. So this one is titled 5.2 like terms and unlike terms. You already have the notes for this, so this video is gonna be a little bit shorter, a little more condensed version. But I'm gonna write it out, even though you already have the notes for it. Basically, what I'm gonna do is I'm gonna first define what like terms are, and as you know from your notes that when it comes to polynomials you can only add and subtract like terms, okay? But basically, like terms, make sure you're paying attention to variables and their exponents. So like terms actually have the same variable, have the same variable or variables with the same exponents. Oops. Things I get handwriting mixed up with printing. Okay. Same variables, same exponents. Same put S in brackets here because sometimes, some terms will use more than one variable, but as long as even has multiple variables and have the same exponents, then they are like terms. So here's some examples of sets of like terms. So for instance, negative 3t is like 4t. Notice they both use t as a variable and they both have exponent of 1, invisible 1 here. Next example, let's say 2m squared is like negative 5m squared. Same variable m, same exponent 2. And maybe the last example, well actually maybe not, is this one that I actually have in your notes. 2gh is like positive 4hg. Okay, so notice that this is gh, this one is hg. It doesn't really matter what order they're in. They both use the same exponent h and g, and both of these have exponents of 1, so they're like terms. And then finally, last is integers are actually like terms. So negative 7 is like positive 5, right? Because if they did have a variable on there, their exponents on those variables would be 0. But there you are. Integers or numbers are like terms. Constants are like terms. Unlike terms, well, basically those are just terms that either have different variables and or different exponents on the variables. Have either different variables or variables with different exponents. Different exponents. Okay, here we go. So it's taking so long, but again, I'm just trying to condense this one because you already have this. You should have these in your notes from the Google Classroom also. So for examples of unlike terms, okay? So, positive 3a is not like, is unlike. Let's say is unlike. I hope you guys don't mind. I'm going to start handwriting. It's a little bit faster. Is unlike negative 2a squared. This has, they both have a's, but this one has exponent 1, this one has exponent of 2. Okay. How about negative 5m squared is unlike 4t squared. Different variables. Again, doesn't matter if they're exponents or the same, the variables are different. I know, again, this is where we're going to get confusing, okay? When we were modeling, and only when we were modeling polynomials, it's okay for the letters to be different, but because you can actually represent these with the same types of tiles, the square tiles, okay? But that's only if you're modeling polynomials. If we're not modeling, as in we're adding here, then you cannot add these two, okay, because they have different variables already. How about 2xyz is unlike, again, negative x squared, y squared, z squared. Okay. Sure, same variables, but these ones have exponents of 2. This one has exponents of 1. Okay. Okay, moving right along. You can still model these like terms with the same types of tiles. Okay, so for example, negative 2a, okay, has the same shape of tiles as 5a. Okay. You can use the same tiles to model them, of course, but when we're modeling them, it's fine. But if you can't, when adding, you can only add these like terms, a's, okay? Okay, so how about we just demonstrate this using an example right away. So what we're going to do is we're going to combine and simplify. Okay, again, this is going to be a condensed version because we already did this in class. We already have notes for this. So here's the first example. And I did this one in class. We have 4n squared minus 1 minus 3n minus 3 plus 5n minus 2n squared. Okay. Basically, what first thing I'm going to do is I'm going to shuffle these guys around so that the like terms are beside each other. So I'm going to have the n squareds together, the n's are going to have to be together, and then the integers are going to have to be together. But the one thing I did note from class is when you're shuffling these guys around, or the real word is translocating, make sure that you take the sign in front of that term with it. So if I'm going to move this 2n squared, it's going to have to be actually negative 2n squared. It's going to have to move beside this 4n squared. And so the next line is going to look like this. Oops. I'm going to have 4n squared minus 2n squared. Okay, and I know there's a minus here already, but believe it or not, that minus got replaced by this minus in front of this 2n squared. Okay, so next I'm going to do my negative 3n. And I'm going to move this positive or plus 5n beside it, like this. Okay. Translocating or shuffling, you need to take the sign in front of it with it. Okay. And finally, this negative 1, this minus 1 is going to move beside this negative 3. So I'm going to move it like this. And now I can actually do the math with these numbers, okay, with these terms. Now in this case, really what I'm doing is doing the math with the coefficients. So in this case, this is actually 4 minus 2. It's 2n squareds. This is a negative 3 plus 5, okay, so for those of you who still need practice with your integers, negative 3 plus 5, well, just try to look at that as negatives versus positives, where in this case the positives are going to win by 2. Okay, and then finally a negative 1, negative 3, well, they're all just negatives, so we're just going to put these negatives together. None of them are going to cancel each other out, so it's negative 4 altogether. So there's your combining like terms and then simplifying. And this is the simplified version because you can't do any more with these. These are all unlike terms then. Okay? Now I've demonstrated that. Now look at what the tiles look like. Because you do have to draw tiles in these assignments, okay? And when it comes to the tiles, I'm going to let you actually do the shortcut. Okay, so now using the tiles, using the polynomial that we had here. Okay, so what I'm going to do is I'm going to draw these guys out as tiles. Okay, so 4n squared is actually going to look like, showing the camera. Okay, the 4n squared is actually going to look like this. Okay, and I think I have a -1 or a -1, so I'm going to shade that in. And then am I a -3 3n. Yep, I'm going to shade that in. Okay, and then I have a -4. This is the polynomial from the original. Okay, so actually, you know what? Maybe I should write that original polynomial here. Okay, so the original polynomial was 4n squared -1 -3n -3. This was, yeah, this is our first example of like terms, combining and simplifying like terms. So what I'm actually doing is I'm just drawing tiles for each of these terms. Here's my 4n squared, this is my -1, this is my -3n, this is my minus, oh, it's supposed to be just 3, sorry, I drew too many. And then I have to draw 5n, so I'm going to draw 5 and tile, and then finally 2 negative square tiles, like this. Okay, so the original instruction was for you to combine the like tiles. Okay, so that means I'm going to move these guys beside these guys and move these beside these. If you want to take a shortcut, you just have to make sure you're paying attention. You can, if you can see what you can cancel out from, from these guys, then you can go ahead and just cancel those out and write out the regular tiles. Okay, the leftover tiles. But for the sake of our instruction, I'm going to take my time here and then actually combine like tiles. So I'm going to draw this again. Okay, so I'm going to draw my squared tiles together. Combine like tiles means you put them next to each other, translocate them next to each other. Okay, so I have my 4n squared and then I have my -2n squareds here. Next I'm going to draw my n tiles. There's my -3n, and I'm going to draw my +5n, and then I'm going to draw my negative little ones. I got 1 there, and I got 3 here. Okay, and now I can go ahead and cancel out my 0 pairs. So next step here is cancel out 0 pairs. And if you remember what 0 pairs are just opposite tiles. So here's a 0 pairs, a couple of 0 pairs. These two can cancel out with those two. I'm going to draw my remaining tiles right away. And please don't forget to draw your remaining tiles, okay? It's one thing to cross out 0 pairs. It's another to draw the leftover tiles. That's important. There's no 0 pairs here, so I'm going to draw them all exactly the way they are together. And here is our remaining tiles. And this should match our answer of 2n squared plus 2n minus 4. And is that the answer that we got for the polynomials? Yes, it is. Okay. Okay. So there, just making sure that you look after the like terms and you do the math with them. Now I'm going to do one example of a perimeter of a shape. I'm going to make it slightly different from the one that you guys got in class or in your notes. So I'm going to make this one look like this. Okay. So let's say I have 2 of these. And then I have 1 of these here. Yeah, okay, so this should be good. Okay, so now here's the dimensions: x, x, 1, 1, x, 1, 1. Okay, or actually, maybe we should leave those out because just to make it look neat. But if you were to calculate the perimeter of this, then you just add up all the sides. So do this step by step: x plus x plus 1 plus 1 plus x plus another 1 plus another 1 plus another x plus another x, and finally plus another x. Oh. Okay, so let's do another line. We're going to combine all the like terms, or just count them actually. How many x's do we have here all together? 1, 2, 3, 4, 5, 6. Yeah, and that makes sense. 1, 2, 3, 4, 5, 6. We have 6x, and then we add up all the ones. 1 plus 2, 3, 4. And so this is a perimeter calculation for perimeter formula for this figure. Again, different example from the ones in your notes, but I hope you like that one as well. That's the instructions and examples for like terms and unlike terms, so hope this is useful to you. View the video if you need it, pause and rewind, etc. if you need it, if you miss anything, but otherwise, if you have any questions, bring it to class and answer those questions. And ask those questions, okay? Don't be afraid, don't be ashamed to ask questions. It's part of learning. Anyhow, have a good day. I'll see you later.